Let's end this now. Don't fall out of sync, Kakarot.
Time to erase you, monster.
In this video, I'm going to be talking about the adenosine pathway. So tumors, they increase CD39 and CD73 when T cells attack them. This is why it's important to keep mitochondrial levels up, because tumors, they actually hate when T cells get mitochondrial support, because tumors know that they are being attacked by T cells. So they will try to disable or disarm the T cell attack by upregulating more adenosine. So basically, tumors secrete adenosine so that the adenosine binds to or interacts with the A2A receptor on T cells. That's how tumors know how to suppress T cells. So basically, there's a step-by-step process of how T cells attack tumors. So first, T cells release ATP. So that's why T cells have to have ATP. Immune system, is a system that demands a high amount of ATP. Then, when T cells recognize tumor cells, they release ATP and then granzyme perforin. Granzyme perforin, it basically triggers apoptosis in tumors. Then also ATP also is pro-inflammatory. The ATP attracts more immune cells and boosts T cell activation as well. Tumors don't like this environment because ATP helps the immune system. Okay, so when tumors are attacked by T cells, they further increase CD39 and CD73. But tumors, they already have those two CDs before they are attacked. So basically, there are enzymes or components of the immune system that actually increases the CD39 and CD73. So basically, tumors, they upregulate CD39 and CD73 as a reaction to IFN-γ from T cells, because T cells use IFN-γ to boost the immune system. Also, another thing that boosts or upregulates CD39 or CD73 in tumors is hypoxia. So hypoxia is low oxygen in the tumor microenvironment. Okay, so basically the signals IFN-γ from T cells and then hypoxia in the tumor microenvironment, and also chronic inflammation, all of those signal to the tumor that the tumor is under immune attack, and then the tumor will convert ATP to adenosine to shut down the immune attack. So it sounds like tumor also takes advantage of ATP, or the immune system's ATP, to attack the immune cells, or to at least prevent or shut down the attack against tumors. Okay, since T cells are suppressed by tumors, if T cells dare attack tumors, since T cells attacking is what causes tumors to release more adenosine to suppress T cells, then the T cells need a lot more ATP. So a good way to boost more ATP for T cells is with chocolate. Chocolate creates PGC1A, which is the master mitochondrial regulator or creator of more mitochondria. So that mitochondria creates more ATP for T cells. Okay, another great way to help the immune system is with tight gut junction proteins called zonula, ZO1, also occludin and claudin. A good way to keep those gut junction barrier proteins tight, they have to be tight in order to make sure that vitamins are absorbed in the gut, and that is with flaxseed meal, because flaxseed contains enterolactone. that supports the tight gut junction proteins occludin and claudin in the gut. This is critically important to help reduce the hypoxia signal that causes tumors to release adenosine that suppresses the T cells. So by helping your gut junction proteins stay tight, you are also helping your T cells fight and battle cancer, especially to keep T cell numbers up. And the reason the tight gut junction proteins have to stay tight in the stomach, thanks to flaxseed, is for vitamin C, because vitamin C has transporters in the gut, and the transporters have to work for the vitamin C to work as well. If the gut junction proteins are loose in the stomach, then the vitamin C transporter will not function correctly, hence vitamin C deficiency. So that transporter in the gut that has to be intact or working for vitamin C is called SVCT1. Now, the reason vitamin C is critical is to help stabilize iron in a bioavailable form, because iron is responsible to reduce hypoxia. So if vitamin C is being transported, then iron can be functional, and then also uh, the iron will help red blood cells deliver oxygen around the body. Therefore, less hypoxia, causing tumors to create more adenosine that suppresses the T cells. Okay, another issue here in the tumor microenvironment is that dying tumor cells, they release ATP substrate to create a more suppressive adenosine via AMP ATP. So a good way to get rid of the dying T cells, or no, not the T cells, but the dying tumor cancer cells, so that there is less ATP substrate to create adenosine, is by helping or supporting the macrophages, because the macrophages will clean up and engulf the dying tumor cells and cancer cells. That way, there is less ATP being secreted by the dying tumor cells that are creating adenosine that suppresses the T cells. Now, a good way to support the macrophages is with mushrooms. So mushrooms has beta glucans, and then the beta glucans binds to the dectin-1 receptor on the macrophage, turning the macrophage into an M1 phenotype that attacks and gets rid of cancer cells. Now, that's critical for the macrophage to be into an M1 phenotype and not on an M2 phenotype, because there are M2 phenotype macrophages that actually support tumors. Tumors, they actually have the ability to make macrophages into M2 phenotypes. But with the help of mushrooms, that should make macrophages an M1 phenotype, so that the macrophages can clean up the dying tumor cells that are creating ATP, that are creating adenosine that suppresses T cells. So quick recap, tumors, they respond to immune attack by releasing more adenosine to suppress the attacking T cells. Low oxygen state, such as hypoxia, is what helps the tumors release more adenosine to suppress T cells. So that's why it's important to keep the tight gut junction proteins, occludin and claudin, supported with a flaxseed meal. Occludin and claudin support the vitamin C transporter SVCT1 to help keep iron in a stabilized bioavailable form, therefore reducing hypoxia in the tumor microenvironment that suppresses T cells. And then mushrooms help turn macrophages into M1 phenotype macrophages to get rid of the dying tumor cells that are creating or secreting ATP that creates adenosine that suppresses the T cells. So that's it for the video. Keep it locked in here on this channel for future videos. I have many more coming. Share these videos with anyone that has health concerns or maybe even already existing health issues, and I'll see you in the next video.